Question 4. Okay, looks like a cosine graph. Yeah, so figure 1 shows a sketch of the part of the curve with equation y equals 4 cos of x. So the equation is y equals 4 cos of x, where x is measured in degrees. Okay, the angle to be measured in degrees. The point P and Q lie on the curve are shown in the figure 1. So let's see where P and Q are. As you can see in the figure, Q in the bottom of the curve and P here on the x-axis. Okay, so state the coordinates. The point P, Q lie on the curve. Okay, so state the coordinates of P and state the coordinates of Q. Okay, first of all, you know the equation. This thing at the start of the cosine function is the amplitude. Okay, so the amplitude, the height of the graph, and the lowest it can go from the bottom line. This is the bottom line, and you should know the cosine graph always starts at the top. Okay, here, highest point, and the sine graph starts at the origin. Okay, like this. Okay, this is how the sine looks like, and this is the cosine. So we don't need it here. Okay, so this thing is the bottom line, I mean the baseline. This x-axis is the baseline, and the highest point where the graph starts is 4, the amplitude. The maximum height is 4 and 4 units down the baseline. So this point, you know, the minimum point on the graph is going to be -4. Okay, alright, so we know the y coordinates now. The maximum is 4, the minimum is -4. Okay, you know the period here, you know, so the period for one cosine function, so the period for cosine of x is gonna be 360, means one wave will be in 360 degrees. Okay, this is the one wave and it will be in 360 degrees. Okay, so this starts at 0, this point starts at 0. Okay, we are just discussing this one wave now for now, and then the next point of intersection with any like x-axis is going to be of 90 degrees, because the one for, you know, the interval, I mean the whole period for one curve will be for 360 now. So we have to divide 360 in 4 parts always, for cosine and sine as well. Okay, so this point will be 90, and then comes the point here, second point is gonna be, so we start at 0 and then 90 and then 180, that's 180, and then this point here P, obviously you keep on adding 90. The first one point here at 4 now, this is where we start, was 0, so you added 90 to get the next point, you got the 90. Keep on adding 90, add 90 to 90, you get 180. So this point is 180, add 90 to 180, you will get 270, and add 90 to 270, you will get this point, which is 360 here. Okay, alright, so this is how the one cosine x function on the curve looks like. And now we have to find the coordinates. Okay, we are moving at the back side, that is gonna be the same coordinates but in the negative way. Okay, like that's 4, so this point is gonna be -90, that's -180, that's -270, and this point would be, since this is 360, so that's going to be -360. Okay, alright, so you can clearly tell the coordinates of P now. P lies on the x-axis, so y will be 0 here. Okay, and the x coordinate is 270. Okay, so you got the P coordinates as 270 and 0. And for the Q, as you can see, Q is the minimum point lying at -180, that's -180 the x-axis, and the y will be, as you can see here, the minimum point on y-axis is -4. Okay, so -180, -4 are the coordinates for the Q. Okay, that was for 3 marks, part A, B and part C. State the number of solutions of the equation. We have to state, okay, let me just write it here, you can't mention the coordinates here. So part A, the coordinates of P are 270 and 0, and for part B, the coordinates of Q are -180 and -4. Okay, For part C, state the number of solutions of the equation when 4 cos of x, which is the given curve above, is equals to y, is equals to 3 I mean. So you already know the 4 cos of x is plotted now. Let me just write it here. Part C. Since you know that 4 cos of x is equals to 3, we want to find the number of solutions for this within the given range when x changes from 0 to less than equals to 18,000 degrees. Okay, x is changing from 0 to less than equals to 18,000 degrees. Okay, you should know that this is the x-axis. Okay, we are taking that in degrees, right? Okay, we have to find the number of solutions for this equation. You know this curve is already plotted above, the cosine curve, and this 3 is another y is equals to 3. So you know y is equals to 3 is going to be the straight line which will pass, maybe that's the 3. If that's the 4, this is going to be the 3. Okay, this point is going to be the 3. Okay, so you will draw a straight line through that. Let me choose a color for it. Okay, this is going to be your line y is equals to 3. Okay, this is the line y equals to 3. So for just let's see at how many points it's cutting the curve y equals 4 cos of x at how many points. Okay, the line y is equals to 3 cutting the curve y equals 4 cos of x at how many points? For only one curve. The one curve from 0 to 360, it is cutting at 2 points. If you see these 2 points here, okay, 0, 1 and 2. One curve is cut out at 2 points with the line y equals to 4, and the restriction for x is when x is greater than 0. Okay, so you have to take the values of x greater than 0. So this is the line x is 0, x is greater than 0 lies here. Okay, so we don't even count this thing. So this is where we start. But this is for one curve. You are getting two solutions at one curve. Okay, the line is cutting at 2 points in one curve with cos of x. But we have to check it till 18,000 degrees. It means if I draw another curve here now, like this, if I draw another curve here like this, it will end at 720. Okay, and another curve, it will end at 1080. So the line will be again cutting, this green line will be again cutting, you just draw it straight, will be cutting at this point. 1, let me do that with black now, 1, 2. Okay, so for first curve you got 2 solutions, for second curve you got 2 solutions, for third curve you got 2 solutions, for each curve you are getting 2 solutions. Similarly we have to go till 18,000. Okay, so first of all let's find out how many curves we have, cosine curves we have till 18,000. So what we will do, we will divide 18,000 by 360, and let's check what does that give us. Okay, that's gonna be 18,000 divided by 360. Okay, that gives us 50. Okay, so we will get 50 cosine curves, and you know at each curve the line is cutting at 2 times now. So for 50 curves we will do 50 curves. For each curve the line is cutting at 2 times, so 50 times 2 will get you 100. So for part C there's going to be 100 solutions. Okay, right? Okay, part C, this was the part 1, and now we do the part 2. Part 2 is 5 plus 4 cos of x equals to 1. We have to find the number of solution again. 5 plus 4 cos of x equals 1. 5 plus 4 cos of x equals to 1. And the range for x values is, x varies from negative greater than negative 720 degrees and less than equals to positive 720 degrees. Okay, x is less than equals to positive 720, greater than negative 720 degrees. Okay, this is the range we have to follow. But first I'm just trying to make it like the curve above. You already got the 4 cos of x plotted above. you can move the 5 on the other side to make it 4 cos of x is equals to 1 minus 5, and 4 cos of x is equals to 1 minus 5 will be minus 4. Okay, why did I change the color? Okay, so 4 cos of x is equals to negative 4. So one of the curve is 4 cos of x, it is already plotted above, and the other curve is going to be negative 4. So y is equals to negative 4 is going to be the straight horizontal line. Okay, see, what does it mean by finding the number of solutions? Number of solutions mean the points where these two curves intersect. Okay, so basically we are finding the points of intersection where the two curves intersect each other. Okay, alright, so I'm gonna erase this thing, the working which I did for, okay, maybe we don't need to erase it. Yeah, this is till 360. Okay, but we only need it till 720. Okay, we need the graph till 720 and we don't need this now. Oh my bad, we don't need the line y equals to 4, but this time we need y equals to negative 4. And you know, well, let me first plot y from negative 360 to negative 720 as well. Okay, this is still negative 360 and the other cosine curve is till negative 720. Okay, alright, so now your line is, since you are solving, 4 cos of x equals to negative 4. So the line y equals negative 4, you will plot it here. This is going to be your line y equals to negative 4. Okay, okay, my drawing is not that good, so my this curve is crossing it, but we can make it, oh, it's not that easy to write with this pen, to draw with this pen I mean. This is your curve till negative 720. Okay, so this was the line negative 4, and you notice with each curve, okay, the reason is mentioned that it has to be greater than negative 720. Now x has to be greater than, so yeah, it's okay, I'm already taking the values greater than negative 720. Okay, so how many points of intersection you can see here for the line y equals negative 4? 1, that's 1, 2, 3, 4. The cosine curve 4 cos of x is intersecting with the line y equals to 4 at these 4 points. Okay, till 720. We started from negative 720 and ended at 720. Okay, from negative 720 to 720 we are getting 4 curves, so we are getting 4 points. Okay, so here you will mention it is gonna be 4 solutions, 4 number of solutions, not 4 solutions, yeah, 4 number of solutions. Okay, 4 number of solutions. Okay, you will get 4 number of solutions here. Okay, similarly we are gonna now see the part 3 which says 4 cos of x minus 3 equals to 1. Oh, we don't have any space. Okay, 4 cos of x minus 3 equals to 1, that is for the part 3, and the x values, the range for this is x varies greater than equals to negative 1080 and less than equals to positive 1080. Okay, so x is greater than equals to negative 1080 and less than equals to positive 1080. Okay, is it? Yeah, both of them we are including negative 1080 and positive 1080. Okay, so first we will just move because we already know the graph of 4 cos of x that's plotted above. So now we will move the 3 on the other side, that makes it 1 plus 3, that makes it 4. Okay, minus 3 on the other side becomes plus 3, so 1 plus 3 gives you 4. Again you have the line, one of the curve is 4 cos of x, okay, and the other curve is y equals to 4. So let's draw the line y equals to 4. Okay, so I have plotted, I'm just gonna make it a bit small and erase the extra things we did for question for the part 2 and 3. Okay, we don't need this line. Okay, yeah, so I'm now gonna draw the line what is that? Y equals to 4. Okay, so y equals to 4 is gonna be here. Okay, and I'm gonna make it a little bit longer, because if I add one more curve in here, that is gonna be for 1080. Okay, you can check, you can just keep on making the intervals, and you will see that you are getting this point 1, that is 720, add 90, you will get something here, add 90, you will get a point, add 90, and then adding 90 to it, you will get 1080. Okay, yeah, because the interval is of 360. Like if you add 360 and 720, you can clearly check, you will get 8 and 7 3 10. Okay, 1080. Yeah, so another curve for 360 period is gonna be at 1080. So we'll get another one here too with the red. I can draw it completely, but this is what you get. Okay, negative 1080. So you find the number of solutions for the line y equals to 4 from negative 1080 to 1080. So both of them are included. If you will look at the condition, x values, both of these points are included, right? So you can find the number of solutions: 1, 2, 3, 4, 5, 6, 7. Okay, so we are getting 7 number of solutions here, right? Okay, so I'm just gonna go write 7 number of solutions. You don't have to write number of solutions, you can simply write just 7. Okay, for part 3. Okay, so this was the question for, it's just the mess for part C, as you just have to describe the number of solutions. So there was a bit more of the explanation there in plotting the graphs. Okay, number of solutions mean the point where the two curves intersect. Okay, you already saw that 4 cos of x is plotted, and the other was y equals to 3, sometimes y equals to 4, y equals negative 4. You plot those lines and you get that. Okay, question number 4 is, okay, no, that's 5.